Hello guys, I hope you are great. Today I wanna take you through basics maths. I have learned that several students take this subject in their university or colleges, their tertiary learning level. So in basics math, we have a certain topic they are called set theory. That's what we wanna start with. Set theory. A set is a collection of well-defined objects. A set a set is a collection of well-defined objects. And this is the definition of a set. A set is a collection of well-defined objects. Definition: what's are well-defined? What does this thing mean? Well-defined means that distinct is a distinct and distinguishable. There can be distinguishable. Well-defined object means that they are distinct and distinguishable. So in set we have some notation. In set we have notation. There are some notation that are used on set. Notations in set theory. One of the notation are one, we have such a like notation. This notation mean belong to or member of. This notation means belong to or member of certain of something. This means belong to. Another notation used in set theory is this one here. Then it's closed. It means does not belong to. Does not belong to or is not a member. Is not a member of. This notation means does not belong to or is not a member of a certain set. There is another notation here. This one here means such that. I know almost every one of you have come across this one, such that. There is another one, the last but not the least. Yeah, it means empty set, or a set with no element. Or a set with no element. After that we'll go to the set representation methods. Set representation method. Methods. In set representation methods, we want to learn how a set can be represented. We have only two methods on set representation, which is tabular, or roster method, roster method, or you can either call it method of extension, method of extension, method of extension. In this method, method extension element of a set are listed within a curly bracket. In this method, elements of a certain set are being listed within a curly bracket, being represented by commas. They are being represented by commas. Let me just write elements of a set are listed within a curly brackets, being separated by commas, which means in this method, which is tabular or roster, or we can either call it method of extension, element of a set are being listed within a curly bracket. I think all of you know how curly bracket is, and are being separated by commas. For instance, e.g., let me just tell you. For instance, if we have a set, e.g., set A, and set A, these are curly. They are listed within a curly bracket. So this is a curly bracket. Then let's say we have 1, 2, 3, 4, 5. 1, 2, 3, and 5 are elements, and they are listed within a curly bracket, and these elements 1 and 2 are element. 1 is element, 2 is element, and they are separated by commas, as you see. So this is how method extension is being represented. Method extension is being represented, and we have another method of representation. Say there are only two: set builder method, or you can either call it method intention. That's the opposite of the other one that we have just learned. The other one was method of extension, and this one is method of intention. In method of extension or set builder method, elements in a set are expressed by a rule or a formula. In this method, they are not listed, but they are represented by a certain rule or a formula. Let me give you some example. Elements in a set are expressed by a rule or a formula. E.g., you have a set A. This set A, that represented within a curly bracket, we have X is such that X is equal to 2n plus 1, 0 is less than or equal to n less than or equal to 7, comma n, and this, I think we learn about this notation belong to where n, sorry guys for that. So we say that a set A belong to curly bracket x is such that x is equal to 2n plus 1, such that comma 0 is less than or greater than n, which is less than or greater than 7, comma n is n belong to a natural number. Natural number is being notated like this: natural number. Then you write the curly bracket. Okay, what do this mean? This is a natural number. Natural number. What do this means? For instance, so let us break it to the method of extension. This is a method that the set is represented or expressed by a rule or a formula. This is just a formula. We can use the formula. It will be our curly bracket, and let's start with 0. We'll start with 0 here. Says with 0. When you place 0 here, 0 times 2, it will be 0. It will be 0 plus 1. It will be 1. Then when you write here 1, it will be 3. Then the next one will be 5. The next one will be 7. The next one will be 9. The next one will be 11. 13. And the next one will be 15. If you are keen. That's how it's being represented. This is called method of extension. This is called method of extension, and this one is called method of intention. Set builder method. This is a set builder method, and this is a roster method or a tabular method. Okay. With that in your mind, we can now proceed to type of sets. Type of sets. We have several type of set, and you wanna start with the one we should start with is number 1. Our number 1 will be finite or finite and infinite set. What do this mean? This means it's a set containing finite elements is called a finite set, while an infinite set contains an infinite number of elements. Let me repeat. A set containing a finite number. A finite is a set containing number of elements. It's called elements, while infinite set contain an infinite number of elements. Let me break it down. E.g., when you have set B contain y such that y is equal to prime number. Y is equal to prime number. The other one, I've not write it meaning. Let me write it for the or sake of the other people. A set containing finite number of elements is called finite set. Finite set. While an infinite set contain an infinite number of set, which the example is there. The second type of set is a singleton set. A singleton set means this set contains exactly one element. It's a set that contains one element. Let me write the definition here so that other people can see, or those who are not understand well can see. This set contain exactly one element. Contain exactly one element. E.g., for instance, A is a set. It contains only an element, one element, which is 8. The curly bracket. It contains only 8, one element. It's a singleton set. It's only one element. The third type of set, the third one, we have a pair set. A pair set. This set contains two elements. This set contain two elements. For example, we have a set A. Set A contain E and H. It's contain two elements. The fourth one, you have an empty set. Empty set. An empty set is a set which contains no element, is called an empty set. An empty set, we can either call it, I think, we have several names for an empty set. We have a void set, a null set, we can call it a void set. Let me write void cell, void, not set, void set, or we can either call it null set. It's an empty set. There are nothing there. And in our is a set. I think you are seeing it well. A set which contain no element is called an empty set, or empty set, void set, or a null set. From where we started from, I told you on the notation that are used in set theory. The other one as well, an empty set. An empty set is represented by this notation. This means that is a empty set or void set or null set, such that x is a month of a year containing 34 days. I think all of us know that there is no month that contains 34 days. A month contains a maximum of I think it's 31 days. 31 or 30. 31 or 30. There's no month that there's no a month of a year that contains 34 days. I've never heard of such a month. So that's a null set. When you get such a question, there's a null set. You get this a null set. That's the theory. The fifth one, we have set of sets. A set of sets. This set that containing sets. I think you're understanding it. This is a set that contains sets. This a set is a set containing sets. E.g., you have a set A, and this set A contains some sets A, B. These are already a set. These are some set 3. It's a set. There's a certain set here. P, Q, R. There's a set. All these sets are contained in one set. They are all this a set. They are contained in one set, which is set A. So these are set of sets. Sixth one, we have sixth type of a set. We have a universal set. Universal set. Universal set is a set which is a superset of all set under consideration. It's a superset. I don't think if you're understanding this thing. A universal set is a set which is a superset of all sets under consideration. They are generally denoted by U. Let me write so that you can understand it well. Is a set which is a superset to all sets under consideration they are donated by generally donated by you or these ohms. So those who did physics, those who are physicians, I think these are signed for ohms. E.g., let set A be A, B, C, and we have a set B A, E, I, O, U, C is P, Q, R, S, and U, which is the universal set. Universal set are represented by U, E, or ohms. The meaning of that sign of ohms. Ohms, I think, is SI unit. Something of that kind, SI unit. They're represented. So, when you find a set called U is a universal set, or is represented by U, E, or the ohms. A, B, C, D, and E. That's it. Also, I think those are the only type of set I know. Then we'll go to the next thing, which is called, let's go to the cardinality. Cardinality, from a simple understanding, our understanding, cardinality is the number of elements in a set. If here, for instance, there's a set A contain certain number of elements, contain element 1, 2, 3, 4, 6, 9. The cardinality of this set, cardinality of a set is represented by, if a set is A, its cardinality is represented in A, then there's some slash. This is a cardinality. This is how the cardinality of a set is being represented. And the cardinality of this A is the number of elements in this set A. We have 1, 2, 3, 4, 5, 6. That's 6 elements. So the cardinality of this element is 6. For instance, let me write the definition of the cardinality so that many of you can understand it. SB are empty set. Then the number of elements of a set is cardinality of a set S. E.g., S is a set. S is a set of curly bracket. I have a problem in writing curly bracket. I don't know even if you two have a problem in writing this thing, curly bracket. I think I've write it well. 1, 3. This is a set S. How can we know the cardinality of this set S? Cardinality is represented by the slash. Cardinality of this thing is 1. Let's count together. 1, 2, 3, 4, 5, 6, 7, 8. So the cardinality of this set S is 8. Again, there's something on cardinality of a set. Two sets are said to be equivalent if they have the same cardinality. Two sets are said to be equivalent if they have the same cardinality. If they have the same cardinality, they have the same cardinality. Or let's say if they contain equal number of element. They contain equal number of element, i.e. A cardinality of A is equal to cardinality of elements in B. The cardinality of elements in A is equal to the cardinality of elements in B. Cardinality is the number of elements in a set. So the cardinality of elements in a set A is equal to the cardinality of number of a set is, let me say in a simple term, the number of elements in set A is equal to the number of elements in set B. That's what we call cardinality. Let's say here we have A. Set A contain element A, B, and C. And set B contain element 1, 3, and 5. Element 1, 3, and 5. And there are 5. Let's count the number of elements in the set A. We have 1, 2, and 3. And the number of elements in set B is 1, 2, and 3. So they are equal. So they are said to be equivalent. The next thing I'm going to look at is a subset and the superset. Subset and the superset. Superset is a very beautiful thing. I think my ranting are visible. If they are not beautiful enough, you can tell me in the comment section so that I can know. Subset and the superset. Subset is a very interesting thing. Subset and the superset. Let's say my father has how many years? My father and Paul. I have, let's say, since my father is older than me, my father is a superset to me, and I'm a subset to my father. It's just like something like comparison. Since my father is older than me, my father is a superset to me, and I'm a subset to my father. Let me write it so that many of you can understand it. A is said to be a subset of B, of a subset of a set B, or the set B is said to be